We wanted to build a car ahead of its time, and this is really a big challenge from the engineering point of view, but it's also rewarding. One of the main challenges is the global homologation from passive safety. And this task is really huge. We want the car to be safe for the customer and to be road legal worldwide. But it's a task that is really big for a small manufacturer, especially when you do that for the first time, starting from scratch.
Developing a globally homologated hypercar is a completely different level. To successfully design, develop, test, and produce a hypercar, we have to go through several steps of research and development.
We are developing this car from 3 years now, and I have seen this simulation thousands of times in our screen. One of the main tasks of the simulation is to create a very detailed model that describes each layer of the carbon fiber, each core, the connection, and all the various subsystems of the car.
Our supercomputers are running 24/7 to improve the performance of our car for safety and stiffness, all in virtual world.
The goal is to have the most perfect correlation between real and virtual testing in order to minimize the risk when you go to crash a prototype that costs €1 million. The design process is quite complex and long. If I want to try to explain it in simple words, it's like this. We start from very rough concept. These concepts are simulated with virtual analysis. Then, once that we find a good result, we start to refine it. And this refinement goes to several loops between design, engineering, to try to find the best compromise.
When we are happy with the virtual results, we start testing. Initially, component level, then system level, and finally, full vehicle level.
Also, vehicle testing goes through 3 different stages. We started with experimental prototypes, we will do prototype testing, and then pre-production testing. In each stage, to find a solution is more and more difficult because the level of constraints increase.
Nobody can promise 100% success for the first time. Sometimes things go wrong.
During the first round of testing on the crash structure subsystem, we had an unexpected behavior. The rail peeled off like a banana, and then the team needed to understand immediately what happened and why we had that behavior that was not represented in the simulation.
We had to react really fast to understand what happened, to propose a new design, to produce new prototypes, to test it again, and then finally, success.
Because things can go wrong is the reason why we do many rounds of tests, and because of this, the team needed to be ready to react to this negative result with proactivity, finding new solution and solving the issue that we encounter.
The scope of the C2 project is huge for a small volume manufacturer.
I was scared before the crash testing, and the people that were with me knows that, because in my experience, I contribute to the design of several cars. I went to several crash tests, and I know that things can go really wrong. For this reason, we tried to look to every detail, to have a robust methodology, and then at the moment, because the first round of crash was really good, at the moment the results are paying for that.
For the first round of high-speed crash tests with the experimental prototype, we used the same monocoque for 5 crash tests. It was so good, it was so strong that we decided to do one more, roof crush.
The next step in development is to further improve our design and correlation with the CAE simulation to permit us to develop even more the perfection that we want to achieve with C2.
Now that the first round of crash tests finished with great results, we have full confidence in our work.
Final production vehicle tests are planned soon.